Autoimmune. Anybody in here know somebody with the autoimmune something? Anything? You personally, right?
Yeah, well, I guess I did. I don't know really because I had my colon taken out, but I used to.
I know some people who have autoimmune disorders, you know,
Like
and
lupus,
ulcerative colitis, the rheumatoid arthritis, that sort of thing. Yeah, the autoimmune disorders. Once again, the body's attacking its own tissues. It's a very painful process. It's a long-term process. Makes people very sick, okay? Different medications, of course, have been coming out for a lot of the identified autoimmune disorders that we have now. And you'll hear the medications being referred to as a biologic. Have you ever heard that? You'll hear that on the commercials. I love how they use that term in the commercials. Because why? I mean, if you pay attention to that commercial now, like the next time you hear about Humira, say for example, listen for that term that they say, biologic.
But they use it for like 6 different issues.
Why?
Because of where it targets.
Because it's a term that's going to capture people's attention. And that's what the media is supposed to do, right? Do stuff to capture the attention. Not necessarily have any reason or rhyme behind what's being presented. They just want to capture attention.
So is it different medications then?
What they're trying to say is that it's a medication because you're suffering from an autoimmune disorder. And biology just simply means life. But that term biologic is going to capture a lot of people's attention.
what do you mean, how do they use it?
Oh, this is a biologic medication. Humira is a biologic medication.
Isn't every medication biologic?
No. Well, no. No. So, autoimmunity, some of the ones that are, and some of these you're probably going to have them be a little more common than others. If you think about, well, of course, the diabetes, multiple sclerosis, rheumatoid arthritis, ulcerative colitis, the lupus, okay?
That's the one I was trying to think of, lupus.
Lupus, that I love, you know, I don't know if any of y'all are Seinfeld fans, but, you know, anything that goes wrong with George, is it lupus? Do I have lupus? Is it lupus? You know, think about that. I knew a lady that had it. She had, you know, it was pretty rough for her. So these are more common autoimmune disorders that you'll see. As we look at what's going to happen with this immune system, well, we know that the immune system begins to decline as we grow because that thymus gland is biggest in children. If you were to remove, or if something went wrong for a child, you know, say around 1 or 2 years old, you had to have that thymus gland removed, what have you done to their immune system? You have pretty much destroyed it, okay? And, you know, for us, it's going to begin to shrink as we get older to a point where it's nothing for that thymus gland. As we get older, we do run the higher risk of infection and cancer. We're going to see that our response to antigens begins to slow down the older we get. Some of these antibodies, some that are good, some that are bad, will increase or decrease as we get older. And due to a decreased immunity in the elderly, they may actually be denied certain medical treatments because they don't have the immune system to actually fight off or to work with that particular issue. So that, people, is our immune system. I just think it's a very interesting system. Now, our next chapter that we're going to move to, the respiratory system. At this time, I'm going to turn over our lecture to Rebecca, our resident respiratory therapy student, who's probably going to know way more than me about this system. Now, I find this system interesting because of how other systems of the body are going to affect it and how it will affect other systems of the body. This is, I've mentioned the emission microscope, the transmitting emission microscope before, giving us a view of something. And so this is actually a electron microscope view of an alveoli. Now, in the structure of the lungs, what do you think about in this structure of the lungs? What comes to mind?
Spongy.
Spongy, sacs. Think of these organs that are right here in the chest. Okay? There is a lot that happens with this system. There's a lot that goes into it to try to make this system work and function correctly. One thing I find very interesting every time I talk about this system is how our breathing is rhythmical and how the breathing is symmetrical. Have you ever thought about that? Can you imagine what life would be like if breathing was not symmetrical? If boom, boom, I can't even imagine. Okay, I'm guessing it wouldn't last very long. Just saying, you know. So, in this system, have you ever had anything that kind of made you gasp for air? Or something that maybe felt like it was cutting off that air supply? How long does it take for you to begin to panic? Just a couple of seconds, right? Okay? And I remember like, well, maybe this is what's wrong with me now that I just remembered this. Okay? I remember as a kid, you know, because every summer we were at the pool, all right? And what was one of the things you like to do as a kid? You used to like to compete against somebody else at the pool to see how long you could stay under the water, okay? So I'm just realized, maybe that's it. Maybe I have now determined what's wrong, okay? But it only takes us a couple of seconds to panic if something begins to go wrong with this system, all right? This system, we have to make sure that our rate of breathing as well as the depth of our breathing is going to match what's taking place in our body. If you think about breathing, and if we are like right now, we're just simply at rest, okay? We don't have to have a lot of thought or a lot of, you know, heavy breathing that's going to be taking place. Okay, we've got this really nice rhythm that's set up, and I don't know about y'all, I'm not telling myself to breathe. Are any of y'all? What about if well now for me, okay, I'm not going to get out and run anywhere unless something's chasing me. But let's say that I was going to have to start my 26-mile marathon. What's going to happen to my breathing rate and the depth of my breathing?
While you run?
I'm going to have, it's going to both increase, right? It's going to be quicker and it's going to be, do you happen to remember why?
For cellular respiration. For the
Get more oxygen?
I've got to get more oxygen to the cells to carry out the cellular respiration. Now, if I've done that, all right, so now I'm thinking about this respiratory system. It has now affected at the cellular level of my skeletal muscles, so therefore I've now affected my muscular system, okay? If that's the case, and I have now increased my breathing, okay, and I've had to get more stuff to the cells, you know, of the skeletal muscle, what other system have I now affected?
Sorry.
I've now affected my cardiac system, okay? So I've now affected the cardiac system. If I affect my cardiac system, what other system have I now affected?
Your nervous system, everything else.
Have I not affected my urinary system? Now, if I'm having to increase, okay, so I got 4 up right now, right? Okay, so now if I have affected these systems, and oxygen, of course, getting rid of the waste, the CO2 are my biggies because that's the gases that get exchanged, okay? So now, in doing that, having those systems that get affected, what did I do to the oxygen supply to my digestive system?
Cut it off.
I've had to decrease that. So I've now affected my digestive system. Do y'all see how I'm going about this? This is a system that, just like the circulatory system, is going to affect every other system in the body. So, breathing, I think it becomes rather important. How is this system clinically significant? What can happen to the color of someone's skin if maybe they're not breathing correctly? They can turn blue. All right? What about maybe the rate of breathing? Could that be clinically significant?
Yes.
Why?
They could have a really high heart rate.
Well, I'm thinking about respiratory now, so let's think about the rate of the breathing, the respirations per minute.
When it's really low, it's often, like in elderly, really low volume of breathing is an indication of death coming up.
If it's too high.
Or if it's too high, or if it's too low. Okay? So this system has clinical significance with it and can affect other systems that will help diagnose or help let us know something about the other systems. Okay? If we think about it, all living cells, for the most part, require oxygen in some way. If we think about all living animal cells require the oxygen, and they're going to produce the CO2. These 2 primary gases for this system. That's what this system's main job is. This system's main job: exchange the gases between the air and the blood. Exchange those gases between the air and the blood. Oxygen and CO2. O2, CO2. In the big picture, sounds relatively easy, right? Doesn't seem like it should be too difficult. Not quite. Interesting though? Very.